Okay, just wanted to let you guys know I'm also recording this, and like I did yesterday's, in case you need to go back over some concepts.
Mhm.
Ooh, hello, Liam.
Hello.
Doggo.
Okay, so today we're going to be going over concepts such as instantiation and extension and implementation and a whole bunch of things to do with classes. Everything there is to know about classes, minus a bunch of things, you're going to learn today. So if you would all be so kind as to watch my stream, that would be magnificent. Lucky if you could come watch my stream. So what we're going to do today is I am first going to explain a concept here, and then we're going to write some code that actually uses the concept, if that makes sense. So, first things first, let's talk about instances. So, if you remember last time here, we made a new type of test class. What this is called is creating a new instance of a class. Basically, a new learning if you can mute.
Yep, sorry.
Yeah. Um, a new a new instance, a new thing. So you could say that whenever a human is born, there it is a new instance of a human because it's another one, but they might have some different properties, right? So, for example, if I said something like array list right, I really need to change my toggle mute key. So what this is doing is it's setting array. It is making it so this box array contains a new instance of the class array list. All right. So, I could make another instance if I wanted to, like, really, just like so. And now I have an instance of an array list stored in a box named array, and another instance of an array list stored in a box array2. But if I make changes to array, they will not happen in array2. And if I make changes in array2, they will not happen in array because they're their own separate instances, if that makes sense. So instantiation is what this is called. You're making new instances, you're instantiating something. It's the essence of Java. And all that is a very, very important concept to remember. Whenever you're making a new X, you're making an array of that thing. Or a new instance of that thing, not an array. Okay. So instantiation is one concept, and then we'll go over it when we actually write code together. The next thing I want to talk about is extension. So if I go and make a little old new class called like other test class, and if I put next to other test class extends test class, then this class, if I go over here and I say create other test class t equals new other test class, and then I do system dot out dot println t dot s, and if I run it, you'll see it prints this string twice. Now, the reason that happens is because in test class, we have, remember the constructor function we talked about yesterday? Whenever you're making a new thing, it runs this. We are setting s to this string. But because we have can I do something to show both of them? That's not a thing. But because we have other test class who is extending test class, that means everything that is here is also inside of other test class. If I added, say, a public void hello, and then if I ran x.hello and then t.hello, because x is an instance of our test class and t is an instance of our other test class, which extends, will print hi there twice because it is running hello. Because the first line here is just running hello directly from test class. Then the second line is saying, hey, this class has everything inside of this class. Therefore, we should run this, if that makes sense. And as another example, if I add a function only in here named like public void aha, make it just print out something. And then over here, if I do t.haha, you know, it'll give it a second, it'll do what I told it to. But if I do x.haha, it will error because x, like I said, is an instance of test class. So there is no function haha inside of test class. It is only inside of other test class. So you can only run it if you have an instance of other test class and not test class, if that makes sense. And another thing is overriding a function. So say if I wanted other test class, when you run hello to print something different, I could do override and then public void hello, and I could make it system you'll see that it no longer prints out hi there twice. It first prints hi there, then it prints this does something different. And that's because if you have an instance of test class, when you run hello, like we're doing here with x.hello, it will just print hi there because, you know, that's what we're telling it to do. But if you have an instance of other test class where we've gone and we've overridden the function, we've changed it only for this class, it will say this does something different because that's what I've told it to print out if you're running it from this class. So, you know, if I made a third class named like, I don't know, another class, and I made it also extends test class, then if I made an instance of this class, b.hello, again, because the hello function is not being overridden in this class. It's only inside of this class. All right, I think that covers really everything about an extension. This override, this @override, is what we call an annotation. You can put it in front of a whole bunch of things, but 99 times out of 100, you're only going to be using @override. Occasionally in Forge, I think we use a few other annotations, but it's mostly just going to be @override. It's a very, very common thing to use. And you don't really need it anymore, but it's nice to have because some Java what makes you have it. Okay. So next up, we're going to talk about different types of classes. Right now, I've only shown you the regular class. But if you look here, There's 3 other types that you need to worry about. Java FX application you're never going to use ever, unless you're making something with it, but none of you guys are going to be doing that with modding. So there are interfaces, there are enums, and there are annotations. Now, we talked about annotations with that override very briefly, but you're probably not going to need to be making your own, so we won't touch on them right now. But interfaces and enums are some of the best features of Java. They are what make a lot of object-oriented programming languages super great and super organized and super cool. So an interface, I make an interface named test interface. Then I can, now you don't write any code inside of interfaces. All you do is in an interface is describe what a class should look like. So I can do like public void hello string name. Or no, you don't even need to do public. You just need to do void hello string name and then say void hi and then like array list array list of, I don't know, string of. So now I can't make a new instance of this interface because that's not how interfaces work. This isn't a class yet. But if I say, new Java class and implementation, I'll just name it that. And if then I say implements test interface, now you'll see that there's a red underline, which usually means an error. But the fact that there's a red underline means it's actually a good thing. So you'll see it says class implementation must be declared abstract, which is something we'll talk about eventually, or implement abstract method hello string in test interface. So if I press implement methods and then OK, you'll see that it just added all the things that were in test interface, but now, they're here and they have a structure. So all that an interface is meant to do is describe what a class should look like. Sort of like an architect drawing a building before the builders actually go and build it, if that makes sense. Now, the last type of class we're really going to touch on is called the enum. And this is super useful. I use enums all the time. They are unbelievably useful. So I'll do something called like test enum. And so there's 2 ways you can define an enum. There's a very, very, very simple way and a little bit more complex way. So for the very, very simple way, you just write things. It's basically a way to tell, I guess, a better way to tell what something is. So now I can have hello, hi, what's up. This is only useful for organization, really. So if I say went to main and then, or no, let's just use our implementatio. And then I'll ask for a test enum inside of the hello. And now, so I'll teach you guys about what I'm about to do in a second, but this is just to describe what I'm showing. So if I do if and I make an instance of our implementatio, like example I.hello, and then I do test enum.hello, it will print out hello. Because if we go to test enum, I asked Java if the test enum we're passing in, with parameters we talked about yesterday, I'm basically telling it, hey, take this all the way over here while you're doing your task. And if what you took is hello, which we talked about here, then print hello. But say we make it hey instead, and we run it. Now it will print out hi, because it is not a hello, it is in fact a hi. Or it is not a hello, it is anything but. And this is what is called an if statement, and it uses what are called conditional operators. Now there are if I can remember correctly, like 4 or 5 or 6, maybe 7 conditional operators that you can use. They are, I'm actually going to make a Google Doc for this real quick, because it's easier. Just give me a second. I will show you what is on my screen. Equal to, and not. This one is called not equal to. Then there's greater than, I think. Yeah, greater than, less than, greater or equal to, and less than or equal to. Is that all of them? Vernon, did I miss one?
I don't think so.
Great. So there's all of them. So I'm just going to use Booleans for this. If you remember, Booleans can either be true or false, right? And this is the simplest way to explain what I'm about to do. So say we had, here, before I do this, I'm going to disable my toggle mute so I can actually speak while I'm typing equal signs. There we go. Okay. So if say we have true equals true. Now these are the same, and the equals sign is asking if they are the same. So this is equal to true, right? Here, I'll use a different thing for that. So this is true. And then we have, true equals false. And that is equal to false, because true is not false. Next we have true does not equal true. And this would be false, because true is equal to true, which means that this is false. Oh, wait, I also need to... Oh, yeah, I should probably talk about or and not. And no, I'm not going to get into bitwise operators. And next we have... Here, I'll talk about... Yeah, we'll talk... So I think you guys have all learned about order of operations in school, in math. So if you put something in parentheses, like true equals true, and then equals true. So this will be true. But the important thing is that this, you can essentially just look at this as true, and then this is comparing if the result of this operation is equal to the result of this operation, then it is true. Yeah, it gets a little bit confusing eventually. So, for example, if we have true equals true, or false equals true. So what this is doing, this right here, is asking if either side is true. If this is true, or if this is true, the output will be true. But if they are both false, then the output will be false. But it doesn't really matter if they're both true. If they're both true, the output will also be true. Pretty sure you can somehow do something so that if they're both true, it also returns it, but that's not something you're ever going to use. I've never used it in my life. And then you have the and, say true equals true, and false equals false. This would equal to true, because false is equal to false, right? They're the same thing. And true is equal to true. So if both of them are true, then this will be true. If one of them is false, say, for example, this one, so now this is false, and this is true, the output will be false. Same if both of them are false. And then you have the not operator. So if you say not true equals true, then this will be false, because this is true, but basically what this does is it just inverts it. So if this is true, then the output, if you put this in front of it, will be false. And then if the statement is false, then the answer will be true, because you're just inverting it. Next up, we're going to talk about these things right here. Now, these can only be used on numbers, as far as I am aware. You might be able to use them on the occasional thing that isn't a number, but 99 times out of 100, it's just going to be on numbers. So first we have greater than. So say we have 5 greater than 4. That is true, because 5 is a bigger number than 4. Say we have 5 is less than 4. This is false, because 5 is a bigger number than 4. It is not smaller than 4. It is not less than 4. So, if we did 4 less than 5, that would be true. And if we did 4 is greater than 5, that would be false. And next up, we have the greater than or equal to, and then less than or equal to. And these are essentially the exact same things, except the numbers can also be equal. So say you had 4 and 4. This is false. If you have the same number, it's always going to be false, unless you have a greater than or equal to symbol. So if 5 is greater than or equal to 4, that is true. But 5 is also greater than or equal to 5, right? Same thing. Same thing. If we go 4 is less than or equal to 5, that is true. But 4 is also less than or equal to 4. So that would also return true. Okay, and all of these are called conditional operators. They operate and on specific conditions. And you don't need to just do these with Booleans. You can test if a string is equal to another string, that would be true. Or if new test class equals new test class, that would also be true, because they're one and the same. You haven't made any changes to them yet. Yeah, you can use these and these on anything, but you can only use these on numbers and really complex math things that you're not going to need to use ever. Okay, so that's conditional operators. Let me think about what else you need to learn. Right, you need to learn about where you use conditional operators. So the main place you use them, like before, is in an if statement. So, you could do if 1 equals 3, like we talked about. This will always be false. So everything inside of the if statement which is everything between these curly brackets, will never be run. But if 1 equals 1, for example, that will always be true. So no matter what, everything inside of the if statement will be run. And yeah, so you can also have what is called an if-else chain. So you can have an if, and then you can have an else if 1 equals 2. Basically, if anything inside of the first thing is false, it will fall to the next else. So this, in this case, is an else if. So if 1 is equal to 1, which is true, it'll run here. But if 1 is equal to 3, for example, that is false. So we'll go down to the else, and it'll run if 1 equals 2. It'll go, this is false, but say if 1 equals 1, it would not run what's inside of here, but it will run what's in here. If, yeah, that is what will happen. And then say these are both false, you can also, you can add another else if 2 equals 4. You can have as many of those as you want. And then if you want to end it, you can have an else. And basically, if all of these are false, it will run what's inside the else no matter what. But there are better ways to do what I just showed. I wonder, does Java have... does have switch. Forgot about a switch statement. So you can have a switch. So it's not the exact same thing. It's used for slightly different things. So say I have switch hello. Or no, I have switch. We can use the enum for this. Switch e. Basically, this will act kind of similar to the if else. So case hey is all system.out.println hey. Remember the enum, we have hello, hi, what's up, and hey as what you call members of your enum. So this is testing if e, what we passed in here, is equal to hey, it will print hey. And if e is hello, it will print hello. If e is hi, it'll print hi. If e is what's up, it'll print what's up. If it is none of these things, then it'll just go to the default, which will just end it. You need to have a break after the end of your case. It's just a thing you need. Say it. So if we ran this, it right now would print hey, because we are passing in testenum.hey, and that makes it print hey. But if I switch this, for example, to what's up, and I ran it, I'm not always going to use these, but it is very useful when you need it. It's 9 times out of 10 just going to be used on an enum. We're going to talk about loops. So there are 2 main types of loops. There's a while loop, and there is a for loop. Oh, yeah, I should talk about that. Okay, as a really quick thing, what do you want? As a really quick thing, why? Why are you erroring? Oh, right. So as a really quick thing, if you have a number, say like int L equals 4, then you do L plus plus or L minus minus. This is basically the same thing as subtracting. This is the same thing as adding 1 to L, and this is the same thing as subtracting 1 from L. So this will make L equal to 5, and then this will make L equal back down to 4 because you made the change. But we'll talk about math in a second. So while true, basically this just acts as long as what's in here is true, it'll just keep on looping through until it becomes false. So right now, this will just run forever and ever and ever until the end of time, or until you stop the program, really. I made it system dot out. Yep, okay. We're really gonna error about an unreachable statement? We'll talk about comments in a second as well. But that's a comment real quick. So now it's just gonna endlessly print Vernon Badwell W until you stop the program, which you can do with the red stop button whenever it's running. And then I'm gonna delete this because I'm never gonna be able to explain for loops. A for loop, it does look a little bit complicated, but it's actually super simple. A for loop, this is the structure you will always be using it as. So for, this is setting up what's called the iterator, which is the number that's going to be counting the amount of times you've looped. And then eventually equal to false, then stop the loop. And then this is the increment. And this is basically just telling you how much to increase the iterator by every time through the loop. So if I do system dot out dot println I, and I run it, this is just going to count. If you look, it counted from 0 all the way down to 99. But say I did, instead of I plus plus, I did I plus 2, I plus equals 2, then I did play. Now it'll count by even numbers, starting with 0, then 2, 4, 6, 8, and it goes up by 2 every time. So, if I did it by 10, it would count up by 10 every time, starting at 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, and not 100, but if I made I less than or equal to, or no, that's the other way, less than or equal to 100, it would then print out 100. Because, like before, what I said is the first thing it is doing, it is setting I to be equal to 0, like we talked about last time. This is just making a variable. And then every single time, it is checking if this is true. If it is not true, it'll stop running what's inside here. And then every single time afterwards, it's increasing this number by the amount you put here. So if I, did I plus equals I, started I out at 1, it doubles every time. And, if I set it to an insanely high number, like, I don't know, that. Oh, is that too big for Java? Yeah. Is that too big for Java? No, it's not. So, it'll just double every time. It's 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, all the way down until it's a number that you can't read just by looking at it anymore. So that's what a for loop does. And there are other types of for loops, but you don't need to learn about that. Okay, last thing, and then we're going to write some code all together. We're going to talk about math in Java. So there's a few ways you can do it. So you can do this with any of the numbers, and you can also add strings together. But I'm just going to do it with numbers because it's easiest. So I'm going to do an int I equals 0. Or no, I should do int j equals 0. Now, okay, as a quick thing, people just use I in here. I'm not sure why. It's just become the standard. If you don't use it, you're a heathen. I don't make the rules. So int j equals 0, right? Now I could do something like j equals j plus 1, which is setting j to be equal to itself plus 1. But there's an easier way to do this. You can do j plus equals sign 1, and then this will just add 1 to j. You can also do this with subtractions. You can do j minus equals like 3. And then the character for multiplication is asterisk, which is shift 8 on most keyboards. And the sign for division is a slash, which is usually under the question mark on most keyboards. So now I could do j times equals 5, which would multiply j by 5. I could do j divided by and then equal to 3, which would then, divide j by 3 and set j equal to that. So if I did system.out println j, it's going to run the program. It's going to do the weird doubly thing. But right here, it did what I told it to, right? It added 1 to j, so it was equal to 1. Then it subtracted 3 from j, which is -2. It then multiplied -2 by 5, which is -10. Then it divided it by 3, which is technically 3.33, but because it's an integer, it just rounded it down to -3. So, did exactly the math you wanted it to. And now you can do like super crazy complex things like j plus equals, I don't know, j divided by 2 minus j minus -j plus 34 times 5 divided by math.pi. And yeah, this would do about, if I made it a float, it would not be 50. So that is some math for you. And if you really need to, you can do some more complex math using math dot. So you can do math.pow to raise something to a power, like 3 to the power of 5. Oh, right, I should probably print it. Or you can do really, really complex math that you're never going to need to use, like atan, or no, you can do asyn if you need to do like trigonometry or graph something for some reason. There's a whole bunch of uses for it. So math in Java is really, really, really advanced. It's really, really useful. And that's how you do it. Okay. Now, I want you to all open IntelliJ. All right? I want you to open up the project that we had before. I'll delete everything that I added so that we are one and the same. There we go.
Object thing isn't there on the normal.
Oh, right. Yeah, I'll just get rid of that too. And this print. Okay, now we are.
Oh, wow, it's not opening. Why isn't that opening?
Okay, so.
Hi. Oh, is that the Villari?
You want to right-click on com.company, then hover over new, then create a Java class. And what we're going to do is we're going to create a new class. You can name it. You know what? We're going to have a specific name this time. We're going to name it Conditionals.
Oh.
If you don't know how to spell it, look at my stream. That's how you spell it. It's right there. Yeah, looks good to me. All right, and what we're going to add in here is we're going to add a public static void run. with no parameters.
Really?
Just
Why?
like how I wrote that.
Oh, yeah, you were jumping.
Okay, looks like everyone's here. So inside of this, we are going to add a loop. Y equals 0, and then int z equals 0. Okay,
If it's in the right environment.
looking good. Okay, so what we're gonna do is we're gonna do for an int I equals 0, I is less than 10,001.
And still, it says there's like a yellow box around it. Is that fine?
Yeah, that's just a warning.
Okay.
It's saying you're doing something weird, but that's okay.
All right.
Mine has a red line under it. I'm not sure what it's for.
Okay, Blocky, you need one more semicolon.
What? Where?
So if you look, oh, no, no, I see what you did. So instead of typing an I, you typed a 1 in the int I. If you look over here, that should, no, over here. That should be an I, not a 1, which is a relatively easy error to make.
Expect.
Yeah, that's fine. That's fine. That's all good. That's what you want. You need to press enter there. Or if you could.
Where?
Right.
I have a bunch of errors on mine.
Bunch of errors on yours. Let's see what you did.
Blocky, I think you.
It would be blue if it was a 1. Alright. Okay, so Lillian, you also made the same mistake. Instead of a 1 for the first thing, it should be an I there. For all three of them, instead of a 1, it should be an I. Like I have here. This is an I, this is an I, and this is an I. They're not ones. If that makes sense. Yeah, it can be capital or lowercase.
So, how was the lesson?
Yeah, I got it. What's up?
He said he had errors.
No, everything's fine.
Oh, okay. Maybe everyone just accidentally typed a 1 like I did. Okay, so now, inside of the 4, so you have your opening and closing bracket. Inside of it, oh no. You don't need to change those to those ones need to stay as ones. That's a number. It still needs to be 10,001. Okay, now go to the end of the line and press enter to automatically make it. There you go. So what you're gonna write is wait. Give me that equal to, you need to make y equal to 1, not 0. There you go. Now come back in here, and what you're going to do is type z equals x plus y, and then system.out.println z. You're down to the dots, to the t, to the I. Oh, right there, Lillian, you want to make it a z that you're printing. and then just x equals. Then you can press the run button. I'm going to press it first to make sure that this is doing it right. Oh, we didn't actually. Now we're gonna go back to our main.java. All right, and we are going to just enter conditionals.run.
And then they're gonna ship him over to try him
in main.java.
because he's in like Alberta or something.
Yeah.
Which is super. Most people wouldn't do that.
Oh, good.
But because Kenda and Courtney already tried him.
Yeah.
Once you've done that, if you hit run,
I started it because he's.
that's an issue.
Well, no, it is. It would be Julio,
It's just
though.
floating point precision.
Julio, right? It's Julio. In his language.
Very, very, very popular.
Mine just
sequence.
came up
Can I
with
see
a
a
bunch of
picture?
ones.
That's very exciting. So it might work out for her after all that she has a horse to work with this fall.
Yeah. Which is super.
It is.
On the tab for conditionals. There you go.
Because he's like a faster
Z equals
Yeah.
X equals Y. You want to change the
Oh, you
equal
don't have a
sign
picture.
between X and Y up there into a plus. We're adding X to Y and making it Z. So if you know, you look on my
Did she
screen,
post a
it's
picture
Z equals
anywhere?
X plus Y, not Z equals X equals Y.
Look at the designs they do with these chairs.
But yeah, you have the Fibonacci sequence. That's exactly what I wanted.
Gorgeous, hey?
Blocky, yeah.
Yeah, like
Well. All right. We wrote our first program that genuinely does like something.
League of Legends chair.
We made it calculate the Fibonacci sequence.
Oh my god.
It got too big for integers because Java bad. He takes the last two numbers and adds them together. So it starts with 1 plus
Look.
1, then it adds it to 2, then 1 plus 2, which is 3.
There, look at it.
Which is 5, no. 3 plus 5 is 8. 8 plus 5 is 13. 8 plus 13 is 21. 13 plus 21 is 34. And so on and so forth until it gets just super, super big. Super, super fast.
Amazing chairs.
Right. There's a program.
That's all League of
There
Legends,
is a Java
right?
program that does something questionably useful.
When are they out now? Does it say they're out?
I don't know.
Okay. If we all understood everything that I spent, the last half hour to an hour explaining, I think we might just
Champions Collection. Wow.
Very, very early beginnings of our.
This is
So if
amazing.
everyone could do File and then Open, and then using what is here, navigate to where your Forge thing that you downloaded was a while ago when you set it all up. For me, it's users 16043 downloads, because it's not what you should do, but and then you just want to click on the Forge folder entirely, and then just press OK, and then press this window.
Mac, would it be open?
Yeah, it's
Yep. Click open.
Do I press this window or new window?
This window.
Liam, for me it says Gradle's build script found. Do I click on
Yeah.
import?
Oh, I definitely should have clicked on import. I forgot that's the thing I could do.
So remember, everybody, if you need to review anything that we've just went over yesterday and today, I've taken video of it, so you can like pause it, and that might be the easiest way to kind of look at things that maybe you didn't quite understand entirely.
Okay, so
I'm talking to the kids.
Is it in your documents folder?
That
Just
would be
look at it,
there.
Mom.
Assume it is. Yeah. Okay. So, Bluebird, you're in the right place. Just wait there.
He's so cute.
Actually, you know what you can do? Press the play button.
beautiful,
Top right. See what happens.
How much? You
Uh,
don't?
Module not specified. That's not.
Perfect age.
Figure out how to fix it.
It's really old.
Oh yeah, I had that issue too.
It's fine. Because Xander's 16 and he looks like he's 8. I thought he was like 10. Yeah, he's super cute.
Okay, so you can just press.
Oh, Canadian warm blood. Doesn't look like it.
So
Well, that's
in the
because
bottom right,
Canadian
there's something that
Warm
says
Blood is
Import
different
Gradle
from Canadian
Project.
Wars. It's not the same.
Click on it. And now this should be doing. It's not what it's going to do for a lot of people, but it's what it should be doing. Not all that much important where it's just opening Forge. I haven't explained anything yet.
He doesn't know how to open the forge.
Okay, so Blocky, I'm watching your stream right now. I see you're in your documents folder. Just click on the Forge folder. Just the Forge-1.15.2 folder. Just click on that folder, and that's all you need. And then click on Open. And then just click on this window. And then click on Import Gradle Project in the bottom right.
Okay.
Okay, now we're just gonna wait for everyone to get through this.
Click on Close on the tip. And then click on Import Gradle Project.
So I pressed import Gradle project, and on the side it says Gradle, then Forge MD, and the
Yep,
Forge
that's what you
MD.
want to see.
Yep.
All right.
Here, I think Blocky has it. I think.
Yeah, Lillian, you've got the right thing. It's just doing things for you. Alright, so once you're all here, I want you to click on the arrow beside Forge 1.15.2.mdk, the root folder, so Forge-1.15.2,
Mine is
whatever.
Forge-1. Is that just shortened version?
Yeah, you want to expand this folder here. Then you want to expand src, then main, Java, com, example mod, and double click on example mod.java. Oh, okay, Lillian. Sorry, that's not where you do it. Remember, you want to click on the arrow beside Forge-1.15.2. Hey, there you go. Now just on the one next to src, click on Java, and com, example mod.
Has no JDK
Okay,
configured.
can you double click on example mod.java for me?
This one?
Double click on that. Now click on setup SDK. And just click on that. No, click on 1.8.
This one?
Yeah, click on 1.8. And now you should be able to run it in theory.
Should I?
So yeah, Lillian, if you could double click on example mod.java and then click on setup SDK in the top right when it tells you to.
So Blocky, you also want to do the same thing. So in the top right, you should see Setup SDK. Just click on that.
Should I try running it now?
Yeah, for sure.
It's the blue bar on the top of your code. Yep. Just click on that. Click on Setup SDK and then 1.8. Yep, there you go.
in the top right, I want you to click on Run Client. Lillian, I don't think you'll be able to just yet. So what you'll need to do is you'll need to click on Add Configuration.
I think it's... never mind.
Do I do that again?
So Bluebird, you just need to, click on the play button. And if it prompts you with a weird thing, just click on Run in the bottom right. And then continue anyways.
Pretty sure I've already done that. I've hit
Yeah.
the...
Mine isn't running.
So... you don't... your play button isn't highlighted.
Okay, so
Neither is Blue's or Lillian's.
yeah, I know the Lillian's. I'm about to. Okay, so if everyone could look here at my stream, I'm gonna show you how to set up the configuration manually. So first thing you want to do is click on Add New Configuration. It's the plus button in the top left. Yeah, click on that. And then click on Application of the Edit Configurations menu that I showed you how to open before.
We're on the other window. So how do we get to run
If
debug
you already have a
configs?
run client thing up here, you don't need to do this. This is just for the people that don't.
Here,
Okay,
screen
you wanna-
share.
I don't.
You want to click on the Add Configurations in the top right, then Edit Configurations, and then the
Oh, got it. Okay.
and then click on Application.
I'm still not sure where
Okay.
that is.
Were you watching my stream?
Yeah, I don't see...
Here, I can help you. So you see where it says run client?
No, Bluebird already has it. He doesn't need to do
okay.
this. He doesn't need to do this. You don't need to do this.
Yeah, you don't need to,
So,
Blue. Yeah.
You want to type in exactly net.minecraft forge. Actually, I'll just type this into camp announcements in a second. So I put what you want to type in to the main class in camp announcements. And then in VM options. Oh, yeah, I don't know why you guys don't.
Oh, really?
If you imported.
I don't know. It didn't load yesterday, so
These configurations.
that's what I thought.
Actually,
But
you guys should have a Gradle menu on the right of the.
it
Not in this window, but in the main window. If you close the configurations window, if you click on the Gradle menu,
there
is
is.
there a task that says Run Client somewhere?
Gradle. It says Forge
Can you
and then
expand that?
tasks and dependency. Gradle.
Is there something in there that says
Yep.
Run Client?
Build setup, help. FG runs, verification, publishing, other. No.
I need to...
Oh, run client is under
it's a folder.
FG
So, yeah.
runs.
If you could
It's in the folder.
build
Yeah.
first.
I want to share my screen, but I can't show
I'm
that to you
fine. Do I
guys.
not have to do this?
It's
You don't
right
have to do
here.
any of this. I'm just trying to troubleshoot on the fly without having the problem myself.
Okay, so I am.
Blocky, I don't think you need to do anything. I think you're
Compiling
fine
now.
right
Okay, there we go. I couldn't figure out how to share my screen while I'm recording here. Sorry. But it's, you guys will see it in the recording.
Blocky has the run client, right?
Yeah, he is.
So does Bluebird.
Yep.
So it's really
Okay.
only, I don't know why you don't have it. Kind of weird. No, blue.
No, blue
it.
has
So
it.
blue doesn't have it?
No, blue.
No,
has
blue
it.
has
So
it.
blue doesn't have it?
An enemy.
Okay,
Can you
sorry.
Close that window.
Oh,
the main
okay, let
window
me
for
have a
there,
look.
an enemy? No. The one, the top
Nope.
level window right there. The run debug configurations.
The configurations that we're looking at. Yep.
And then close IntelliJ.
Use the red X in the top left.
Okay, so I ran it when the run client thing was there, and it just now said build successful.
Mm-hmm.
Is it supposed to open anything, or?
Good.
In theory, it should.
It opened Minecraft for me.
Windows,
Like
and it
the game
expects
itself.
everyone to be on Windows.
I'm-
Okay.
Oh, I see. Okay. I'm just going to quit out of
Okay,
it.
so can you just go back and open up IntelliJ for me? An enemy urchin. Remember, you need to use this spotlight search in the top right. Oh. No, that's not.
Well, she's got it.
Yeah, there it is. And just press enter.
Alright, well, see ya.
Yeah, see ya.
Bye. Thank you.
Bye.
So Blocky,
Bye.
Bluebird, you guys are free to go as well. And yeah, can you just
Mommy
open
Bell
up
can
the
go
Forge,
too, because I found it.
The Forge project again? So click on forge-1.15.2 for me. Double click on it even. Yeah, it's gonna do its thing.
Spencer Cat, do you need to? Oh, and he's definitely.
There you go.
Spencer Cat, do you need any help with anything?
Nope.
Nope. Okay, then you're free to go if you want.
Okay.
I like how you let everybody go at the end. It's like, okay, this is enough. It's time to go. That's great.
Wait, click on.
Okay, cool.
Refresh the Gradle.
Yeah.
So click on Gradle in the top right. Yeah, in the very right.
The folder?
That says Gradle. It has like an elephant on top of it.
It's right under the magnifying
Oh.
glass on the very top right
Not of your screen, of the
of the
IntelliJ
window. Yeah.
Yeah, you want to click on that.
Oh, there.
Yeah,
Okay.
she's hovering.
Did you see that? Do you see where that is? Okay. I can't tell. No, I don't think so, because the only two people that could actually do it is Blocky and Blue.
Tomorrow morning I won't
Yeah.
be here. And then the
Yeah.
afternoon I'll be here.
That's fine, I think.
Actually, I might be able to make it.
Okay.
Because it's a 45-minute appointment at 9:15. So
Oh, okay.
I'll probably make it.
Okay.
But that depends on if I even wake up.
It's early.
Yeah.
That's right. Don't worry. Don't worry about it. We're gonna it was really great
Yeah.
having
I might actually
Sean on.
go
Yeah.
back home tomorrow on my way back here and then pick up the books to read again.
Nice.
I remember reading it and then it was really good. I like it a lot. Yeah.
Yeah. He's a really good writer. Yeah. It's the kind of stories that I like too. Adventure fiction. All right, how's she doing here, Liam?
Okay, you want to press the button on that.
What? I'm sorry. It's just reloading.
So what is this doing? What is this doing? It's reloading the Gradle, and the Gradle is the
Would it be in the
actual.
would it be in tasks? Liam?
Oopsie.
Would it be in tasks?
Yeah. Just, yeah, open. Because that's where I found mine.
I don't know. Maybe.
Yeah, open up tasks. Now open up FG runs. Open up FG runs. Just click on the arrow. And then run client. There you go. Double click, I think. She's on a
there we
Mac,
go.
though. I don't know. There we go. Perfect. I don't ever know if it's double click or single click or how many clicks.
My logic is just click until it works.
All right, good.
Usually it works. Liam,
Ah.
Hi.
do you know Spigot just hates empty args?
Spigot. If Spigot does what?
If Spigot just doesn't like empty arguments.
Empty arguments? What do you mean empty arguments?
Like, I don't know, cause you, never mind, I'll explain it later.
Yeah, I'm just sort of managing my team right now.
Yeah, I know, that's why
5 minutes to scrim.
I know, that's why I decided that I'll just ask you later. Alright, perfect, and now your Minecraft is open, so...
Alright, that's exactly what we want. Alright, I have to go.
Great. Okay, so you can just quit game and you can close out of everything, and that just means everything's running the way we need it to run for tomorrow.
I will see you all at...
Thanks. Thanks, Lillian.
Yeah,
Thanks, you
I'll
guys.
see you tomorrow at...
All right, bye.